Hi, this session is going to be about how to develop new ARMS positions, how to find errors in your XML, and how to look beneath the calculations and into the ARMS core code and see what's happening. So this obviously requires that you have a developer version of the ARMS system, and we're going to start by looking at the ARMS position developer workspace. So we have loaded this and it's empty to start with. And we're going to start by pretending that we want to check a new XML that we're trying to send to the ARMS system. So I've prepared, let's now look at the documentation, and we can see that we're going to work with a regular plain vanilla interest rate swap, and we can see all the parameters that are required and non-required. And then I have prepared also an example of this, and we're going to have a simple CX swap. It's going to be fixed float with the maturity of about 10 years. So let's see how this looks when we try to import this then using the developer. So we start by going to the tab File Import, and we write the file path and the name of the file that we want to try out. And we're going to try the one swap file, and then we press Recalc. And then we can see that it doesn't work. So we get a message in the warnings window. Error parsing XML at position 687 closing tag. So let's look at the file again, and then we can see that we have an error here. So let's fix it. So leg 1, now it's fixed. So we save it and we try to recalc once more. And now it's reading, so we get a position XML. But we can see that the import error is not empty. So there's still something wrong with this file. So we can open up this message, and then we can see that we're missing a required frequency that has a non-valid number. So let's go back to our XML and try to see if we can locate the frequency. We have leg 1, and there we see that we have an empty XML tag that we need a frequency. So let's have a frequency 4 for Swedish, the non-fixed leg. So let's save that as well, and then we'll go back and see if we can get this XML to be read into the system, and like so. So now when the import error is empty, then the position is correctly imported and mapped to the risk factors that we have. And if you want to see how it looks like, you can see the imported XML there and what it looks like on the inside, and mapped on the inside right here. Okay, so what can we do with this now? Well, first of all, we can see if we can have a present value and some value at risk. So then we go to the Values tab, and we set a value date. That's which date we place the swap at when we value it. We set a market date. So that's the date for which we read the rates and quotes. And the end risk date is used for ending the calibration of the valued risk. So we set these to yesterday, everything, and we have this in euro. And let's have a decay of 0.97 for the decay dependent VAR methods. Confidence 99, Monte-Carlo pass 1000, historical samples backwards 250 business days. And then let's see if it calcs. So it does. And then we can see, what do we have here? We have all the risk factors that this swap is dependent on. So we here see that we have all the way up to the 10-year node of the CX swap curve that we activate for this swap. and all the notes below that as well. And as we're calculating in euro, but the swap is in SEK, we also have the euro-SEK exchange rate as risk factors. The euro is base, so that's 1, and we have then the SEK versus the euro, that's currently at 0.1. So these are the risk factors. And then we can look at the columns, what we have. We have the present value of this swap is currently at minus 284,000. The notional value of the swap was quite large. I think it was 100 million. And we have a stressed value. And the stressed value comes from the stressed value curve. So if we would mark the reset out and recalc in order for it to take, then we can switch, we can have other values, and then we get a different stressed value. Like so. So this affects the valuation of the swap, and we get a stressed value. And all the risk that we calculate comes from the stress. So we can do a reset and go back to our original market state. And then we have some alternate risk methods that we have pasted here in this test function. So we have the Monte-Carlo version, we have the simple delta, the delta gamma, historical simulation, and expected shortfall historical simulation. So we can see, well, 1,000 Monte-Carlo pulse is perhaps a bit too few. So let's run with a 10,000 and see if that changes. Yes, not much. Since we have a swap, it's fairly linear in the risk factors. So the Monte-Carlo and the delta gamma and the historical simulation come fairly close. Obviously, the historical simulation here is equally weighted, and the other ones have a covariance matrix with a decay, so we can set this to 1 to have them on an equal basis. So then it's a bit higher. So depending on what we set, we could set 0.94, the classic risk metrics decay, and then we get something more close in time. And here at the end, we also see the rollout of these cash flows. So first we have all the floating coupons, as we have 4 per year. There's quite a few of them. And we can see that the Swedish rate switches from negative interest rates to positive forward rates somewhere around 2019. And the first cash flow of the floating is actually fixed, since this is a swap that has already begun. And we set let's go back to the XML. We set the first fixing to 0, which means that we're going to have a 0 cash flow for the first one. And below we get also the fixed coupons from the fixed leg with a reverse sign for these. So what can we do now? Well, we can now play around with this some more by adding a position directly in the code. So we can move to the code window here in the position testing, and we can ask the system to add a position for us on top of the ones that we're playing with. So I prepared some positions to play with. So we have a vector position, and we're going to use a bond, and we're going to remove the comment, and then we're going to add a bond with a notional of the equivalent of the swap for a fixed leg bond, and then we're going to compile. And what we're doing now is that we're adding a position to the vector positions that we're analyzing. So we can see we have the swap, and then we recalc and we get a bond. So now we have the cash flows also for the bond with the 100 million principal, and we can see that we have placed these so that we are actually neutralizing all the fixed cash flows in kroner. because those are positive and those are negative. So they're almost perfectly matched. And then we can see that the VAR of the total position went down, which is obviously what we intended to get. So we neutralized the risk along the curve. So we only have risk on the principal and the floating leg. So effectively we have made this bond into a floating rate 3-month FRN with the principal at the end. So now we can see we have the market value of both positions, and we see that they have an equal amount of risk, both positions. And here on the rest of these you get the total portfolio, or the vector of positions, total risk. And the last feature I'm going to show before I end this testing is that you can have also a fixed scenario. If you have fixed scenarios defined in the database, interest rates up, so we can see that the position, if we move the interest rate up by 100 basis points, we get a present value going from 10 million euros to something slightly less. There's not much effect on this, since most of the valuation comes from having the big principal in SEK, which is then about the equivalent by a tenth in euros. So this is the ARMS Position Developer Workspace, which is a very good place to play around with positions. And well, just before we leave, we can also see if we want to view some code as we're running this. We can go to the library, and we can open the code that we're actually running, and we can go into the position type. So here we can actually look into the swap, and we can put a breakpoint somewhere. So if we want to test to see how this rolls out its amounts and coupons, we can put a breakpoint on the swap code and enable it, and then run it, and then it stops. And then we can see that we have a vector of amounts and dates and coupons, and then we can check these out by looking at the immediate window. And then we can see that we get the same cash flows as we had out here. So by using this developer window, we can go into the code and check it out. So F5 to continue. Well, that's the behind the scenes. Thank you very much.